Hello, everyone. How are we doing today? Enjoy your extended vacation. So we are ready. We are all rested and refreshed. Maybe, hopefully. All right. So um, I don't think I have any announcements. Our test is scheduled for the second month, so February 2nd. So we still have a little bit amount of time. Um, have you guys seen the review for the test already? Each test has the test review on Canvas, on Web of Science, sorry. Yes. And so, you start looking at those questions as we're going along. Other than that, last time we did measures of central tendency, the mode, the median, and the mean. Somebody remind me, how do you find the mode for a data set? How do you find the mode for a data set? The most common item, or the item that happens most often, that is the mode, right? Some of the advantages of the mode, that it is easy to calculate. Some of the disadvantages of the mode is that it does not necessarily give us the center of the data set. Yes. If I have a whole bunch of numbers and then I just have one number repeated twice, say for example, numbers 1 to 100 and the number 0 happens to be repeated twice, that's the mode, but that's not nowhere near the center of the data. Yeah. But another advantage of the mode, it can be used in areas where we do not have numerical values. For example, the mode may be the dress most people wear on the red carpet. The mode may be the dress most people wear, right? You can't, dresses aren't numbers, but you can still apply a mode to them. How you find the mean? Add up all the numbers and then divide by the number of numbers you have. So if I have 3 numbers to find the mean, I add the first, the second, and the third number together to get a total, and I divide that by 3. Yes, that gives us our mean. The advantages of the mean, again, it's easy to calculate. Two, it tends to be in the center of the data unless the data is skewed. But generally speaking, the mean tends to be the center of the data. Generally speaking, I didn't say this the last time, but the mean is an unbiased estimator. The mean generally is a good estimator for the center of the data. Yes, but one of the things is that the mean is not resistant. Yes, the mean is affected by outliers. So if I have 3 numbers in my data set, 0, 1, and 5 million, the mean is going to be affected by that 5 million. Yes? Think about it. I'm entering numbers 0, 1, 5. By accident, I put 5 times 10 to the whatever, 5 million. All of a sudden, nothing's going to be right because that 5 million just throwing everything off. Yes? Right? That's just it. All right, and then the median. How do you find the median? Oh, yes. Order of size. Right. So if a median, you put the numbers in order of size, and then you find the number in the middle. If it's an odd number, then that's easy. That's just the number in the middle, right? But if it's even, there are 2 numbers in the middle, so you take the average of those 2 numbers. Yes? There's a simple formula. If it's odd, add 1 and divide by 2, and that will give you the position of the center number. If I have 5 numbers, add 1, 6 divided by 2 is 3. The third number in line is going to be the center value. Yes? So if it's odd, add 1, divide by 2. If it's even, you have to divide by 2, and that gives us the first of the 2 center numbers, right? So if I have 8 numbers, what's 8 divided by 2? The fourth number is one of those 2 numbers I need to take the average of. Yes? The fourth and the fifth number, take the average of those 2 numbers to find the median. All right? Questions there? The median advantages and disadvantages. The median is more difficult to calculate because you first have to put all the numbers in order, right? Imagine if you had 500 numbers, right? The median is a little bit more difficult to calculate. But the main advantage of the median is that it is resistant. The median does not get affected by outliers, unlike the mean. So the median moves very little if you have outliers in your number in your data set. For example, again, if I have three numbers, um, 0, 1, and 5 million, the median is going to be 1, yes? Right? This is just going to be that middle number. That 5 million is literally not affecting the median at all. Questions there? And we were looking at right here, and we looked at a number set. If the number set is symmetric, the mean, median, and mode will line up. They'll all be the same value. If it is skewed to the right, i.e., the outliers are on the right side, right? This often happens in home prices, right? Most home prices are around a certain price, but then a few people have mansions. You guys know anybody from mansion? No. A few people have mansions, and a regular home may cost what, $250,000 now, and a mansion is like 7 million, right? Right, those right here, those are outliers that skew to the right. What will happen is that the median will move less than the mean, and so the median will be smaller than the mean if we are skewed to the right. Yes, and the reverse happens if we are skewed to the left, if the outliers are on the lower side of your data set. Questions there? Something that would happen is with electronics, the time till the electronic breaks. Generally speaking, electronics, they either break just as you get them, or they last a really long time. Yes, and so you might have a few outliers. A few of them break just as you get them, or a few days after you get them, but most of them will last a long time. Yes, this data is skewed to the left, and in this example right here, again, the mean gets pulled the most to the left, and so now the mean is smaller than the median. Questions there? The one thing we need to get to right here is something called the weighted average. In the weighted average, we do not simply add all the numbers up and then divide by the number of numbers. Instead, we apply what is called a weight. A weight is a numerical value or a percentage that we multiply each score by to make some scores more important or more valuable. The classic example of the weighted average is your calculation for your grades, right? Assignments that you guys get to do at home that are not proctored, those tend to have smaller weights, while assignments that are more important or you have in class, those tend to be more important. And so those have a higher weight than your ones that you do at home. Yes? For example, in this class, your 6 tests are 60% of your overall grade. Yes? So that's the weight that's being applied. That's the weight that's being applied to your test scores. Yes? Questions there? I think the quizzes are 12%. Think? Something like that. Or 15%, one of the two. And so again, the quizzes have a smaller weight. So even if you get 100% on your quizzes and then you get 80% on your tests, your grade will be closer to 80% because 80% has more weight. Yes? Questions there? Whenever you try and find a weighted average, instead of dividing by the total number of numbers, you divide by the total weight instead. Okay? When you find a weighted average, you divide by the total weight, add all the weights up, not the number of numbers. Questions there? Example. Suppose that your current homework grade is 98.57. Woo-hoo-hoo. That's actually happened to me before. People come and say, look, my homework grade is 98.7. How come this thing campus is saying my grade is 70%? People, ask me that before, and I have to explain, yes, your homework grade is important, right? But your homework grade is only 8% of your grade in the class. So even though you're doing very well in the homework, your test grades are dragging your grade down. Yes? And then your current quiz grade is 92.7, which is 12% of your grade. And your homework grade, your classwork grade is 59.29, which is 10% of your grade. Calculate your current course grade. Again, this right here, you do it by using what's called a weighted average. So what you do is you take each score and you multiply it by its weight. So 98.57 gets multiplied by 8%, the weight. And then you take the 92.7, you multiply that by its weight. And then you take the 59.29 and you multiply that by its weight. And then you add those three numbers up. And again, you have three numbers, correct? But you do not divide by three. Instead, you divide by the total weight. And that will give you your course average or your weighted average. Questions there? Another classic example is you're calculating your GPA. Your GPA is a weighted grade. And what happens is the weight is based upon your letter grade, and A is a 4. Your weight for an A is a 4. A weight for the a B is 3. A weight for a C is 2. A weight for a D is 1. And the weight for F is 0, right? And that's how they calculate your GPA, right? They take each A that you get and multiply it by 4 to add those up, and then divide by the total weight, and that's how you calculate your GPA. Questions there? Yeah, in high school, when you have a weighted GPA, certain courses give you, they go out to 5, I think, or 6 basically, because technically it's a college level course. And so some people's course class GPA can be higher than 4 because of those extra weights. Any questions there? We're done with the mean, median, and mode. Last time I showed you how to calculate the mean, median, and mode using SALT. Would you like me to show you that again? Yes. All right. So what you would do in SALT is that you would open up an Excel file. Hopefully, there you go. You open up an Excel file. Let me double check something right here. Let me double check. You open up an Excel file right here, and let's say we have what can I put? Let's say we have number of shoes. So basically I went around asking students how many pairs of shoes they have, and these are the scores for the number of shoes people have. Again, these are just random numbers. What you would do right here is you want to save this as a CSV file. That stands for comma separated values. So you go to file and then you go save as. And then what you want to do is go to your downloads folder. I'm going to put it in there. And then instead of an Excel workbook, you want to change it to a CSV right here, CSV, comma, separated values. And then you want to save it right here as this. And then what you want to do is go on to WebAssign. Actually, I can do it fast. I can just go to SALT. So type in a WebAssign and then SALT, SALT, because they have a free version on the internet. You click here, upload CSV file, and this one is just raw data. If I hadn't made it into a frequency table, remember how we made a frequency table, right? The classes and then the frequencies, you upload it right here. We don't do two-way contingency tables anyway here. And so raw data, you upload the raw data. I guess this is it from today. Upload. And then there's only one thing. Why put shoes at the top? So note that this column representing shoes. You could have had several columns, and then you can import all of them at once. And then these are my numbers. One of the things, if there's a mistake, you can click on add row, and then you can add in another number of shoes. Say 4 more shoes, like so. And if you want, you can delete rows as well if there are errors. You can click here to edit the row if you want to change the number. All right. And then once you have this done here, you've done the hard part right here. You have these all do different calculations. We'll get through most of them, but the one you want is the descriptive statistics. The descriptive statistics calculates everything that you need. We'll do the standard deviation today. The quartiles, we'll do all this stuff today as well. But basically, I just want to show you the mean. So I'm going to uncheck everything else. Well, I'll leave the median as well. And so you can see right here, the mean number or the average number of shoes people have is 3.4667. And then the median is 3. Yes? So let's test the knowledge right here. Because the mean is larger than the median, is this data set skewed to the left or is it skewed to the right? No, everyone's going to answer. I'm going to ask for a raise of hands in a second. I'll give everybody a chance to think about it. The mean is larger than the median. Is this data set skewed to the left or is it skewed to the right? Ready? All right. All those who say skewed to the right, raise your hand. All those who say skewed to the left, raise your hand. And the correct answer is the data set is skewed to the right. When you have right, you have larger outliers on the right side, larger numbers right here, and that will pull the mean to the right. Make it larger. Questions there? It does other things like population standard deviation. I'll show you what that is in a second today. But anyways, that's our good buddy thought. I don't think it does any charts for me today. Oh, there we go. Look, it did a frequency table for us. So scores between scores three people had a score of had 2 pairs of shoes. 6 people had 3 pairs of shoes, and so forth and so on. Right here is making a frequency table for us. Questions there? Here is a box and whisker plot. Right here, we'll tell you what that is as well, hopefully today. I don't think I need we did a dot plot as well. So a dot plot, see right here, 3 people. Sorry, I did the wrong zoom. Be nice to me. It's not them. Oh, there we go. So right here, 1, 2, 3 dots. So 3 people had 2 pairs of shoes. 1, 2, 3, 4, 5, 6. 6 people had 3 pairs of shoes and so forth and so on. That's a dot plot. The point right here is that salt should be your best friend. Because of it, I don't really think you need a fancy graphing calculator. We will let you use solve on text. All right. Questions? All right, cool. So let's get back to what we were doing. All right, so meme mode, basically this is how they did back in the old days using Excel. You guys ever used Microsoft Excel before? How to type in the equations? But these days we just do it in Salt. All right, so you can get started on your 3.1 homework. That takes us into 3.2, measures of a variation or measures of spread. We just did measures of central tendency, the measures to find the center of the data. This right here is measure of spread or how spread out the data is, right? So for example, if my data set is 5, 5, 5, 5, and 5, that data set is not spread out at all, right? I have the same score exactly, yes? And so a measure of variation for that will return a very small value, most likely 0. There is no variation at all, right? But if a data set is 1, 12, 30, and then 500, those numbers are spread out quite a lot. And so your measure of variation should return a large value, saying that the data set is spread out. All right? And so literally that's all your measures of variation are just giving us a number that can tell us if the data are the numbers close together or are the numbers spread out. All right, so the most simplest way for measuring variation is something called the range. The range is found by subtracting the lowest from the highest value of the data set. You can think of it as a cap. This is the highest the numbers will go, and this is the lowest numbers will go. We'll subtract them, and that'll give us our range for our data set. A classic example is temperature. These are, it's not a bad place to live, huh? The lowest temperature is 51. and then the highest temperature is 63. That's not a bad place to live, yeah? I don't know where they made these numbers up from. But anyways, that's how you find the range. Simply identify the highest, identify the lowest, and subtract them. And so this 12 right here in this example is saying that there's a range of 12 degrees. All right? That's all it's saying. There's a range of 12 degrees. Questions there? That kind of tells us that this place in particular, the temperature range is quite, temperature doesn't change by that much. Yes? Basically, that's what it's saying right here. Yes? Unlike in Tallahassee, where the range for the temperature will go from what 102 all the way down to a high of, I think we have days with a high of like 35. The high for the day is 35. So from 102 to 35, that's a much wider range. Yes, much more variability in our temperatures. Questions there about the range? The advantages of the range is that it's easy to calculate. The disadvantages of the range is that sometimes it's difficult to know how to use the number, right? 12. Does that mean that the highest temperature is going to be 85? No. All it tells us is that the highest and from the lowest is, that's all. The numbers are spread by 25. It doesn't tell us how hot it's going to be or how cold it's going to be. All right? Let's do that. Variance. Excuse me. Before we do variance, we need to do something that's called a deviation. Anyone knows what a deviation is? A deviation is the difference between your scores and your mean. Your deviation is the difference between the score and the mean. So if my average score for a test was, say, 80%, and then someone on that test scores 70, then their deviation will be negative 10. Okay? The deviation tells you two things: how far you are from the mean and whether you are above or below the mean. On that same test, if someone scored 90, then that deviation will be positive 10, right? So, again, my average for my test was 80%. If someone scored 70% on that test, then the deviation would be 70 minus 80 would be negative 10%. That negative 10% is telling us that they deviated from the mean in the negative side. They scored 10 points below the mean, right? On the other hand, if someone scored 90% on that test, then their deviation would be 90 minus 80. That gives us 10%, a positive 10%. That means that they scored 10 points higher than the mean on the test. Questions there? Okay. Your variance is a measure for your average deviation or an approximation for the average deviation for a data set, right? So if I had 10 scores, some of them higher than the mean, some of them lower than the mean, your variance is an average of your deviations, okay? Because of that, your variance is a measure of spread, yes? If all the scores are really close to the mean, your variation will be small, right? But if all the scores are far away from the mean, then your variation will be high. Yes? Your variance, sorry, will be high. Question there? There are two ways of there are two ways of calculating the mean. Remember, your mean is either a sample mean or a population mean. We use X bar when we're calculating a sample mean, and we use mu when we're calculating a population mean. Yes? You guys remember that from back in the day? No? Maybe? And thus, there are two measures of deviation. One when you're measuring your sample deviation, and one when you're measuring your population deviation. Let's just there. Again, we talked about this a second ago. If your deviation is positive, it means you're above the mean. If your deviation is negative, it means you are below the mean. Now, scientists thought this was the greatest idea ever. Hey, this is a great way of trying to find my spread, find my average deviation. But when they tried to find the average deviation, something went wrong. Does anybody happen to know what went wrong when they tried to find the average deviation? Anybody happens to know what went wrong when they did it? No? Maybe I should demonstrate. Maybe I should demonstrate. I should demonstrate. I should get me a clean sheet. Da, 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 da. Let's get a clean sheet right here. Delete, delete, delete. Give me 5 numbers. 7, 17. Hold on. It's not writing for some reason. Hold on. 7, 17. 25, 30, 32. Let me see one more number. Huh? 13? All right. All right. Go ahead and find the average for these numbers, please. So I can estimate the average right here. 32 is the highest, 17 is the smallest, so it's between 7 and 32. The average is 32, 19 and a half. 13. So what's the average? So this is going to be mu. Mu is going to be equal to adding all these numbers up, 7 plus 17 plus 25 plus 32 plus 13, and dividing by 5. And the answer we got was 18.8. Yes? Now let's find the deviations for each score. So let's take the score. We're going x right here, and then we're going to do the deviation x minus the mean. 7. Let's do the first one together. What is 7 minus 18.8? What's 7 minus 18.8? Negative 11.8, correct? Go ahead and do the remaining deviations for me, please. 17, 25, 32, and 13. Go ahead and do the remaining deviations for me, please. Again, remember, scientists say, hey, these deviations are great. Yes, I could find deviations all day long. And then since they're a measure of the distance from the mean, if I take the average of all the deviations, then that should give me the average spread, yes? But they discovered that there is a problem. They discovered that there is a problem. After you have found all the deviations, all 5 of them, go ahead and find the average of those 5 numbers going to be. After you found all the deviations, you have 5 numbers. Find the average for those 5 numbers from the 3. And I can tell you right now what the answer is going to be. Go ahead and find the deviation. So add those 5 numbers up and you divide by how many? 5. Divide by 5. Add just 5 numbers up and divide by 5. Tell me what happens. Go ahead and find the average. After you find the 5 deviations, go ahead and find the average. Add all those numbers up and then divide by 5. actually know what the answer is going to be. Although you guys just made up those numbers up, right? Right? I didn't have these numbers before we started, right? You guys just made those numbers up, yes? What happened? All right, first, give me a list while I'm waiting for everyone to do the calculations. What's the list of the deviations? For 17, the deviation is negative 1.8. And then the next one is 7.8. And the next one is 14.8. And then the last one is negative 5.8. All right, we have our deviations. And so we want to find the average. So the average is to add all those numbers up and divide by 5. Yes? What happened? What happened? What happened, D? Negative 11.8 plus negative 1.8 plus 7.8 plus 14.8 plus negative 5.8. And then divide this by 5. And the answer is, drum roll, please. And the answer is, what? What's no one say it out loud? The answer is 0. No, that's not what you guys got. This is literally them. There is no deviation. There is no spread amongst these numbers. Is that correct? Is that correct? There is deviation, right? Some numbers are higher, some numbers are lower. It doesn't mean, yes? But I thought you said this is going to be easy. Just add all the numbers up and divide. It turns out that because the mean is the center of the data set, all of your deviations, when you take the ones that are lower and then the ones that are higher and you add them up, they will always total to 0. If you add up all of these deviations, your deviations will total up to 0 because the mean is exactly in the center of the data set. And that's when they realized I need to do something else to find my average deviation. All right? Questions there? So what did they do? What they did was they decided on a way to get rid of the negative sign. What they decided to do was get rid of the negative sign on these numbers right here, but it did it in a very specific way. So yeah, so like I was showing you just a second ago, is that if you take your deviations and you add them up, the answer is always going to be 0. The negative values will cancel out the positive values because the mean is dead set in the center. And so what they realize is that they need to get rid of the negative numbers. And if you think for a while, there are 2 ways that you can get rid of a negative number. One is you're going to simply throw a negative sign out, yes? Yes? The other way, the way they decided to do was to raise it to the second power instead. Any negative number raised to the second power, for example, negative 2 multiplied by negative 2 will become positive, yes? And so they decided to get rid of it that way instead. Why? It turns out the mathematics, when you do it this way, is much easier than when you do it with your absolute value. Mathematics of squares, you can take a derivative of a square term very easily. It turns out the mathematics of squares are much easier to do. And so because of that, we do it this way instead of just throwing out the negative sign. Questions there? Comments? Queries? Concerns? So what this formula is saying here is this. Go back to the table we just had a while ago, and then get rid of all of the negative signs by doing this. Go the number we have, raise it to the second power. So 11.8 squared. Go ahead, fill out this column right here. Square each of these numbers right here. I ain't got no calculator. What's 11.8 squared? Negative 11.8 squared. 11.8. I can leave the minus sign off because I know it's going to go away. It's 139.24. Go ahead and find the remaining 4 squared deviations, as it were. And then find the average of those five numbers. Find the square deviation, and then find the average of those five numbers. This will not be zero. Yeah, 2.2. Looks like we have to fix the 25 and 32. There's not 7.8 and 14.8. Hold on. Make sure we have our numbers right. So this one should be 6.2. Yes?
Yeah.
And then this one should be 13.2. All right, thank you. Yeah, so square each of these right here. Now add those five numbers up and then divide by 5. Okay. Which is got the time. This month. I'm glad you having fun. All right, what's the numbers? What's 1.8 squared? 3.24. 6.2 squared? 33.6. That six squared is 36. That'll be higher than 36. What's it gonna be? 38.44. 13.2 squared. 160. 174.2. 24, just 0.2. And then the last one, what is 5.8 squared? 33.64. Yes? So you add up all of these squared deviations. We add up all these squared deviations and then divide by 5. What do you get when you add up all these numbers and divide by 5 and divide them by 5? What do you get? So let me write this down in mathematical thing right here, notation. You put this right here means to sum or to add up. So add up all of the squared variations, right? I'm using this column right here. So I'm adding this column, these numbers up. And then after I get that answer, I divide it by 5, which is n, the number of numbers. And the answer is, what's this? What's the sum first? When you add them what answer you get when you add the 5 numbers up? 388.8. You divide that by 5, and then the answer is 77.76. This answer we get right here goes by a specific name. This answer is called the variance. We call it the population variance, to be more precise. But this number we've calculated right here is the variance. It is the average of the squared deviations. It is the average of the squared deviations. Questions there about the variance. It is a measure of spread. Find the square root. That's our next step, is to then take the square root. To undo all the squaring, we then take the square root of it. Question there. But before I do that, question on the variance itself. The variance itself is a measure of spread. The more spread out numbers are, the larger the variance is going to be. Yes? But there is a problem with this number in that this number is a sum of squared values, correct? So this does not actually give us the spread of our data. Because remember, we are looking for the average deviation, yes? This is the average of squared deviations, right? What do we need to do to go from something that's squared down to a regular value? We have to take the square root, yes? And when you take the square root, that will give us something called the standard deviation. Not the average, the standard deviation, all right? And that is our last calculation in this little section right here. I am out of space. So where can I write that? I have to write on the next line right here. Any clue? So the variance is going to be 77.76. The units, not units, the symbol for the variance, the population variance is sigma. Again, another Greek letter. We write sigma squared is going to be 77.76. Again, remember the variance is your sum of squared deviations. If you take the square root of the variance, what is the square root of 77.76 rounded to 2 decimal places? 8.82. 8.82. This result is called the standard deviation. It is not the average deviation. We know that's going to be 0, yes? The standard deviation is, this is the standard process that we want all of us to follow to find our deviation or our average spread from the mean. The standard deviation tends to be a little bit higher than if we took the absolute values. Remember, we could have done that instead. Take the absolute values. The standard deviation tends to be a little bit larger, but only a small amount. And the reason why we go with the standard deviation is mathematically it's much easier to calculate and also to do other calculations based on it. So we go with this instead. Question there. There's one more wrinkle that we need to go through. But before we go through our wrinkle, so therefore they give us this very, very fancy formula. Notice right here you have sigma squared. This right here is your population variance. Notice right here, we're using mu, the mean, and we're using capital N, i.e. every single person is being used. If this class has 6 scores, if I use all 6 scores to calculate my variance, that would be a population variance. Yes, like so. And then we have this thing right here. This is called the sample variance. What's the difference between the two formulas? There are two differences. The first is the mu is gone, right? All we have is x bar. And then there's a smaller, another difference in that instead of it just being dividing by n, we're now dividing by n minus 1. Anybody happens to know why we're dividing by n minus 1? Anybody? So let me explain. Your sample variance is computed by using this formula right here, correct? Do you remember when I said right here that whenever you calculate a sample, we almost know for a fact that it's going to be wrong? Remember that? Right? If I wanted to find my average grade for my class, I take everyone, all 25 million, and I find my average. That's going to be the average for the class, yes? But if I take a sample of 10 people and I find that average will almost never be the exact actual value, right? There's built-in error when we're using this value right here. Yes? So every time we go x minus x bar, there's a problem, there's a mistake. X minus x bar, there's a problem, there's a mistake. Yes? Research has shown that if I use this formula right here and I divide by just n, the answer is going to be too small. Too small. Yeah, the answer is going to be, hold on, 5 by 5. Yes, the answer is going to be too small. And so they make an adjustment to fix that problem by dividing by a number that's slightly smaller. Divide by n minus 1 instead. That's where this n minus 1 comes from. When you calculate a population variance, you divide by n. When you're calculating a sample variance, you divide by n minus 1. The sample variance when you divide by n tends to be a number that is a biased estimator. It tends to be too small. It needs to be made a little bit larger. This is how we fix it. Questions there? Questions there? That's why, for example, if I went back to salt, oh, salt's on the other side. That's why, for example, if I go back to salt, where is my good friend salt? If I go back to salt right here and I go back into the descriptive statistics, you'll see right here that in salt that there are two calculations. There's your population standard deviation, and then there is your regular standard deviation. And you note right here that where is it? The standard deviation of the regular standard, the sample standard deviation, there we go, is going to be a little bit larger than your population standard deviation. It's always going to be a little bit larger because I'm dividing by n minus 1 instead of dividing by n. All right? Question 3. I think I might be out of time. Again, the last thing right here, to go from variance to standard deviation, we simply need to take the square root. And that is because the variance, we're doing squared numbers, yes? We took the average of squared numbers. To go from square back to regular, we take the square root. And thus we have our standard deviation. So simply, you have, again, two of them. You have your sample standard deviation using the letter S, and then you have your population standard deviation using the Greek letter sigma. Questions there? Comments, queries, concerns? All right, cool. All right, so I'll do this next time, but you have we will do this in class on, I guess we'll do it in class, right? I have an example right here. But we'll do one of these in class. One of our in-class assignments will be to do one of these tables, calculate the variance and the standard deviation. We'll do that in class on Friday. Let me take attendance and then I can send you guys on your way.